Hi, I'm Sam, and for today's blabbering, I want to talk about two topics that actually do not correlate to each other. And the two topics that I'm spouting nonsense about are merge sort and binary tree traversal. And yes, binary. And but don't you worry. I'll try my absolute best to explain this video for you guys so that we don't have to cry. But first, we need to talk about the first topic for this project, and that is merge sort. Yeah, I will not say it like that ever again. Now, what is merge sort? Well, it's simply about sorting. I'm sorry. Merge sort is one of the sorting algorithms in data structure and algorithm that you can apply to coding. Merge sort is really well known for its efficiency and stability, as but for me, I find I find it really popular because it's much more easier to understand too. So, how can you use it on our projects or job related projects? Well, database is one of them, like arranging the accounts by name or by numbered order. Or we use it in data analysis, finding patterns, frequency distributions, or looking for closest pairs of numbers. Pretty cool, right? Anyways, let's talk about the steps that are required to understand merge sort much more easier. First off, divide. We're basically dividing the list or array recursively into two halves until it can't no longer be divided. Basically, they're now single. For the second step is conquer. Each subarray are solved individually using the merge sort algorithm. For the third and final step of the process is merging. The sorted subarrays are merged back together in sorted order. The process continues until all elements from both subarrays have been merged. So now we have the steps on our minds. Let's set a visualization on how it actually works. So I've set up a visualization for everybody to see on how merge sort actually looks like. First, we need an array. On our array, we have 80, 10, 40, and 60. And as you remember from a first step of the process of merge sort, we need to divide them, which is 80, 10, and 40, 60. As you can see, it divided them into halves, which splits them both on both sides. Next, since, as I said back then, we need to keep dividing until it can no longer be divided, which means you have to divide them until they are now single. As you can see, all of each elements are now separated. Next is to conquer and merge at the same time. So we need to put them back together, but we also need to sort them out together. So we put them back together and sort them also. As you can see, from 80-10, it is now 10 to 80. But since the other side is 40-60 and it's already in ascending order, it's still the same as 40-60. But this is the part where merge sort actually comes in play. We need to do it again and put them all back together, but now in ascending order. As you can see, we sorted them all back together, which is 10, 40, 60, and 80. That's how the visualization of merge sort usually works. So, now we can visualize how merge sort really works. Let's start explaining on how to make the code in C. Now that I'm on my PC, let's start on making the code on how to actually merge sort on programming C. So, let's start with, of course, the library itself. Include std.io h. We can do it again. but this time stdlib studio library. Now we need to make an int main parenthesis. Oop, wrong. Not those are not curly braces. Now we need to make an array. Let's start with the array that I have used as an example on my presentation. I mean. So let's start making it, and it's 80, 10, 40, 60. Next, we're gonna make the size of the array. Of course, this is going to be really cool. Size r underscore. So now we're getting the size of the r divided by the size of the element of r. So hold on, I'll show you an example of what this does. Okay, so what this does is we're calling out the binary input of the in total of each array in the element. So since an integer has 4 bytes, each of these has 4 bytes. So since there's 4 of them, we count 4, 8, 12, 16. So that means inside of this is 16, and inside of one element is 4. So that means 16 divided by 4 is equals to 4. There it is. That's why, and it's really, this one is really nice. So whatever you put, let's say let's say 90 for a bigger one. So whatever you put, now it's 5, right? So 4, 8, 12, 16, 20. 20. Now we use the calculator again. We get the 20 divided by 4. We get the same number of elements inside of this array. That's why it's really flexible, and I recommend you to practice using this one. Next one is, oh no. Next one is we make the merge sort itself. So first I'm gonna make it merge. Oop. In the merge, we're gonna call out int r, which is the original array. Number curly braces. Now we're calling out the int left, then int middle, then int right. Uh, Now we're gonna make a temporary integers for the for loop, so that I don't have to type it in the for loop all over again. J and let's say K. Next one is we're making out the first half of the array. So that means it's int n1. Middle. We're calling out the middle. So let's say this one's the middle. And now we have to minus it by left, I believe so. Yes, we're gonna minus it by left plus 1. Yes. Now we're also gonna do it again on the n2. Which is, but this time we're gonna call it the right side. So I believe it's right minus 1. Yes. Now we're gonna make a temporary temporary arrays for our splitting. So now we call it n1. This one should be n2. So next part, we're gonna try and copy it. Yes, we're gonna try and copy it, the elements to our temporary elements. Next one is for loop. We're gonna make another for loop. Since we have call out I, we can call out I instantly. Is equals to 0. Next one is the condition, which is I is equals to 0, of course, typical. And now we're gonna call plus plus. We're gonna increment it. Now we're gonna assign L, which is a temporary array, to I is equal to array. We're calling out the array, and then we're gonna call out left plus I. Yes, left plus I. Now we're also gonna do that for the right side. Let's just copy this one, set I to J, and this one to R, and this one to J. Now, this time we have to call out the right side of the array. So we're gonna call out middle. We're gonna call the middle first, and then we're gonna plus 1 and plus J. Plus 1 and then plus J. So uh whatever is J, it's going to make it same. So, oh wait, no, sorry. These are not zeros. These are n1s and n2s. Yes, there you go. Now, we're gonna do the same thing, but this time it's going to be RK is equals to right. It's J. And J plus plus. And then outside of the if statement, but still inside of the while loop, we're gonna increment K. So next one, I wanted to do this just to make sure, like, sometimes it doesn't really print out and sometimes it does. So that's why I want to make an exception. I want to make a just in case while loops to print out everything. So basically, we're gonna make a while loop again. Oh, my bad, not line 0. And then we're gonna call I is less than n1. If I is less than n1, then we can assign k is equals to left, which is the temporary array to I. And then I plus plus. Then we're also calling out k plus plus. We're also calling out k. Now we're also gonna do this to the left side, to the right side, I mean. So we're gonna copy this, make another while loop, and but this time we're gonna call out j. We're gonna call it n2. We call it j. We call it j. Not this one. Next part, I think that's the next part. And then next part, we're gonna make the merge sort itself. We're gonna make copy. Wait, no. Oh my god, there's a for merge sort. Camel case. Highly recommended. Now we're gonna call out int I, int R. Let's say, oh no, nothing. And then we're calling out the left. Now we're calling out the right. So now we're gonna try and call out each one and try to merge them. Yeah, we're gonna try and merge them all together. Okay, so now if left is less than right, which is, you have to do that, is int m, just we're calling out the m is equals to left plus, and we're gonna add a parenthesis to prioritize, r minus left divided by 2. Now, still inside of the if statement, we're gonna do a recursion, which is basically calling out itself. Int r, then l, and then we're calling out the middle merge sort. And for the second time we call it, we're gonna make it different. So now we're calling r m plus 1, which is, I believe, it's the right side of the array. Plus 1. What am I doing? That's plus 2. And then we're calling out the right side. Next one, we're gonna call out the merge function, which it has the original array, L, M, and right. But we're gonna call them on each with corresponding signs. So L, and then M, and then R. Now, we're gonna try and merge them, put them on, we're gonna call out this one. I believe we're now calling out this one on the main function. So merge sort. Merge sort our array. I'm calling out the array. And then 0, which is index 0. And then the right side. How do we do that? Well, we're basically gonna do we're calling out the size, and it's going to be the -1. So we're calling out size, which is it has 1, 2, 3, 4, 5 elements. And then we minus 1, we're calling now 4. Or I believe it's 40. Whichever of 3. So now we're calling out size underscore r is minus 1. So there's, yeah, 1, 2, 3, 4, 5 minus 1. It's bound to be 4. Right. And then we make another for loop. I'll just do this. And then 4. Or you can also do this, whatever you like. Like, it doesn't really matter. It's just my personal preference. 0. We're assigning I to 0. That's letter O. Okay. Next is I is less than array size. We're going to call array size of the array. Scythe. And then we're going to increment it. We're going to increment it, and then we're going to call out the printf. %d, which is the placeholder for integers, and we're going to add a comma so it would look nice. And then we're going to also call out the array. So it's array. And of course, don't forget to assign. And then, yeah, return 0 to end everything. So 80, 10, 40, 60, and 90. Oh, it's now going to be 10, 40, 60, 80, and 90. Uh-oh. I forgot the D. Oh my god, I forgot the D. That is embarrassing. Wait, what? I think it overflowed. But it called out 80 perfectly. So I think 80, yeah, on the first part. So I think it's the while loop or the for loop that's problem. I'm calling out the J, I'm calling out the K, calling out the I, calling out the I, and it's okay. So now calling out the I and K, K, but this one's J, J. Yes, everything's okay. Oh. Oh, okay. I called out an I instead of a J. Dang. See there? One wrong move, and that causes everything to fail. That's why you have to keep that in mind, everybody. So, as soon as you run, I think it fixes everything. Yes, there it is. With that extra comma, because it's a comma. Well, that's it for this video, and I will now explain about tree traversal on the next video. Thank you for listening. Bye bye.